to target and suspect screening workflow over. Let's just jump right in and take a look at the screening interface for this sample. First, I want to show you where it came from, and that's from the Quant program, batch at a glance, looking at the target and the qualifiers, calibration table. This is what we're used to. I've got two samples, a cal and a fortified. And in this new Quant 10.1 release, you'll see on the tools bar several new entries, including screening LC. And that's going to bring up the user interface that I'm looking at right here. And if I look at malathion, you can see several interesting parts. The target screening presentation is designed to be simple. So I've got targets and suspects. Let me just look at the targets. And there's malathion, which has gotten a green. So green means it passes all the criteria. There's green, meaning it's a hit. There's some that are, well, maybes, and then there's a whole lot that, well, we're not interested in. So in going through malathion, you can see the criteria that have been laid out here. There's retention time, and for a standard, I've got one, so the retention time looks good. And I've got a final concentration calculated. Other evidence of mass match score, which is shown here in the isotopic cluster. You can see that that does match up very nicely with the ratios that are expected from this compound. And then if I look further, I can see there's my target, 331, low mass accuracy. And in this case, I found 6 confirming ions. Now that's a lot because sometimes, as you notice up here, I don't always get 2 ions like the Santai regulation is looking for. I might see the molecular ion, but I don't necessarily see a confirming ion. Each compound has its own chemistry. So down here I have the complete spectrum with all the detail. Isotopic cluster is shown blown up here. I could see that by looking at a part. And then I've got the target-oriented game at the collision energy of 20. And you can see how fragmentation has taken this molecule and broken it apart because I don't see the original 331 in the spectrum, but I do see some fragments. And then at 40 collision energy, I see even more fragmentation. So that's the supporting evidence, which is showing you other ions that are confirming from the molecule. If I go on now and let's take a look not at the targets but the suspects. So looking at the suspects, again, I've got some that meet all of the criteria. I've got some that are, well, maybes, and then I've got plenty that don't. So looking at the suspects, let's take methoxyrin. So that's been confirmed meeting all the criteria are met. If you look at the mass match score, which has to do with the conformance to the expected with the isotopic cluster, yeah, that's a good score, and you can see they really match very well. If I look at the target ion, yes, it's there. Mass accuracy is good, and I've got 4 ions that are confirming from the different collision energies. So there's a spectra at 0 collision energy again, and there's the collision energy of 20, and I see quite a bit of fragmentation. There still exists the 229 molecular ion, but as I hit it with 40 with collision energy, you can see that it's pretty much fragmented the entire molecule. And that gives me information about the structure because these molecules do fragment in a very predictable manner. Thanks for your attention.